The mid-20th century presented an era defined by profound geopolitical tension. The Cold War cast a long shadow across the globe, compelling nations to seek definitive strategic advantages. Within this climate, the United States Air Force grappled with a critical limitation for its long-range bomber fleet: range and endurance. Conventional jet aircraft, while swift, consumed prodigious amounts of fuel, necessitating frequent refueling or imposing severe operational restrictions. The concept of an intercontinental bomber, capable of reaching any target on Earth without pause, became a paramount objective. This ambition fueled a vision that transcended the conventional boundaries of aeronautical engineering. What if a bomber could remain airborne for days, even weeks, impervious to the constraints of fuel logistics? The answer, at the height of this technological race, appeared to lie in the harnessing of an unprecedented power source: the atom. The Convair B-36. Peacemaker, already the largest piston engine aircraft ever built, was an imposing symbol of American air power. Yet even this titan faced the inherent limits of fossil fuels. The stage was set for an audacious experiment, an endeavor to merge the destructive potential of nuclear weapons with the boundless energy of a nuclear reactor, aiming to create the ultimate weapon platform. The pursuit of nuclear-powered flight commenced earnestly in the late 1940s, evolving into the Aircraft Nuclear Propulsion, or ANP, program. This monumental undertaking involved a collaborative effort between the United States Air Force and the Atomic Energy Commission, engaging industrial giants such as Convair, General Electric, and Pratt & Whitney. The fundamental premise was to utilize the immense heat generated by a compact nuclear reactor to power jet engines, theoretically providing unlimited range. Before a fully functional nuclear-powered aircraft could be developed, however, a crucial intermediate step was required: the testing of an airborne reactor's operational characteristics and, most critically, its radiation shielding. To achieve this, a specialized test-bed aircraft was commissioned. The Convair B-36H, a formidable intercontinental bomber, was selected for conversion due to its immense size and payload capacity. This aircraft, designated NB-36H and informally known as the Crusader, underwent a radical transformation. Its bomb bay was modified to accommodate a 3-megawatt nuclear reactor known as the Aircraft Shield Test Reactor, or ASTR. This reactor was not connected to the aircraft's propulsion system. Its purpose was solely to generate radiation and heat, allowing scientists and engineers to evaluate the effectiveness of various shielding materials and configurations in a dynamic flight environment. The challenges were immense. The culmination of years of intensive research and engineering manifested on September 17, 1955, when the Convair NB-36H made its maiden flight from Fort Worth, Texas. This was not a test of nuclear propulsion, but a profoundly significant demonstration of an airborne nuclear reactor's safe operation. On board, the ASTR reactor was activated, generating heat and radiation while the massive aircraft traversed the skies. To mitigate the profound risks, the crew compartment was heavily shielded with lead and rubber, creating a hot zone around the reactor and a comparatively cold zone for the flight crew. Due to the experimental nature of the mission and the potential for catastrophic failure, the NB-36H was always accompanied by an Air Force C-97 Stratofreighter carrying a team of paratroopers. Their grim directive was to secure the crash site should an accident occur, and stark indicator of the perceived danger. Over the ensuing years, the NB-36H conducted 47 test flights, accumulating 215 hours of flight time. During 89 of these hours, the reactor was critical, actively generating nuclear fission. These flights provided invaluable data on neutron and gamma radiation attenuation, heat transfer, and despite the technical successes demonstrated by the Convair NB-36H, the aircraft nuclear propulsion program ultimately faced cancellation. The NB-36H completed its flight test program in March 1957, having provided crucial insights into airborne reactor operation and shielding. It was then decommissioned, its reactor removed, and the airframe scrapped. The ambitious goal of a fully nuclear-powered bomber capable of indefinite flight proved to be an exceedingly complex and costly undertaking. The sheer weight of the necessary shielding, coupled with the intricate engineering required to adapt a reactor for propulsion, presented formidable obstacles. Furthermore, the strategic landscape was rapidly evolving. The advent and rapid development of intercontinental ballistic missiles, or ICBMs, offered a swifter, potentially more survivable, and ultimately less expensive method of delivering nuclear payloads over vast distances. These developments shifted military priorities away from the complex and inherently hazardous concept of a nuclear-powered bomber. Environmental concerns regarding potential fallout from an airborne reactor accident also played a role in the declining enthusiasm for the project. The Convair NB-36H, a symbol of unparalleled technological ambition during the Cold War, thus represents a monumental scientific and engineering effort that pushed the boundaries of what was conceivable. It did not lead to a production aircraft, but it unequivocally demonstrated the feasibility of operating a nuclear reactor in flight.